Hello, Math 8 students. This is our final video on Open Up Resources Unit 1, Lesson 14, which is called Alternate Interior Angles, but I'm focusing on parallel lines cut by a transversal. We are going to get started today with a quick poll that reviews everything that we did yesterday. Students in class are working on their quick poll right now. Online learners, you guys should pause the video long enough to answer this question. You're just answering it on your own paper, thinking it to yourself, giving yourself the time that you need. Pause the video long enough to do that. Students in class have finished the quick poll, so you should have finished your answer now if you're watching the rest of this video. And while the correct answer is that it is 109 degrees, the justifications that were offered have been incorrect. So online learners, please learn from the mistakes of these in-person learners. The reason I know that this angle is 109 degrees is just as we saw yesterday, we can take this angle and we can translate it into this position. Therefore, these are corresponding angles. The justification that would have earned full points is 109 degrees because corresponding angles are congruent. You also could have talked about a translation. If you talked about a translation, that also would have earned full points. However, saying vertical angles are congruent, while that may be a true statement, it does not apply to this problem, and it does not address the relationship between these angles. So, please make sure you take out some notes right now. We're going to call these our warm-up notes. These will not be turned in, however, they are a chance for you to learn, and I want you to copy down this problem, including the correct response. Let's get those taken care of now. All right, with that added to our warm-up notes, let's now quickly review everything from our last video. We have this diagram where we also reviewed Lesson 9 summary. And from the Lesson 9 summary, we were able to talk about two things, and one of them is that vertical angles are congruent. That means that this angle here is 30 degrees, and directly across from it is a congruent angle that's also 30 degrees. And again, we justify that with vertical angles are congruent. But we also observed that we have a straight angle, which we remember from our previous lesson on triangles, and a straight angle adds to 180 degrees. We did introduce a new word for that, and that is supplementary. When we have a straight angle and it adds to 180 degrees, the word that we use is supplementary. That simply means it adds to 180 degrees. We also were able to identify that when we have parallel lines, although we can identify all of the angles when two lines intersect, we can then take that and translate, let me review with that, we can translate this set of angles into position here and recognize that these angles down here correspond to these angles up here. And so those are corresponding parts, or we would maybe say corresponding angles are congruent. So those are three different properties that we have addressed so far today. We are going to talk about one more. And before we do that, we need to talk about the Are You Ready for More, which was your homework. So make sure you have your homework in front of you so that we can review your answers there. All right, are you ready for more? We were supposed to find the measure of angle x, but we had to take some baby steps in order to get there. Who can tell me one of the baby steps that they took before making it all the way over to x? Xander, what did you do to get started? This one? You use this angle here, 55 degrees. And what did you do with this angle? Okay. Okay, what you're saying is correct, but you're jumping ahead. You do recognize that this is a triangle, and the triangle adds to 180 degrees, but you're jumping a little bit ahead because in the triangle that would add to 180 degrees, I only have one 60-degree angle. So let's tie that into the 55 degrees. This is only one angle that I know. Can I figure out other angles in that triangle? Okay, tell me that. How do I figure out the other angles in the triangle, focusing on this 55-degree angle here? Using this 55-degree angle here, tell me how I can find another angle in that triangle. Lucas? Yeah, vertical angles are congruent. So that tells me that this 55-degree angle is going to be the same as this angle because vertical angles are congruent. And now I know that this is 55 degrees. How many angles do I know of that triangle? I know 2 angles. Can you use that information to find the third angle of the triangle? What would I do to find the third angle of the triangle? Zeta. So you know that this all is going to add up to 180 degrees because of the triangle sum theorem. So you added the 60 and 55 and got 115. We know that this next one, the missing angle, that's why I called it M, the missing angle plus the 115 degrees is going to equal 180. Does that summarize what you said? So how do I find the measure of angle M now? Callista? And that tells me that M, the missing angle, is equal to 65 degrees. Knowing that this missing angle is 65 degrees, how does that help me find the measure of angle X? Garrett? Nope. That's not going to help me. 65 minus 180 isn't going to get me there. What would I do, Garrett? Vertical angles are congruent. If this is 65 degrees, that tells me that this right here is also going to be 65 degrees. So the measure of angle X is 65 degrees. Now moving on to our next problem where we're going to address a new property. To get started, I have had students in person trace on their diagram or on their tracing paper this right here, which is the line segment PQ with the midpoint M. I'm going to skip ahead to where it says lines L and K are parallel, T is this transversal, and M is the midpoint of the segment PQ. So though T is the whole entire line, if I'm just focusing on PQ, I can see that the midpoint here is M. And just using that information, that PQ is a segment and M is the midpoint, I want you to experiment with that tracing paper. What happens when you rotate a line segment 180 degrees about its midpoint? Well, we have a line segment with a midpoint. Rotate it 180 degrees and tell me what happens. That means our tracing paper is moving right now. We are rotating segment PQ 180 degrees around the midpoint. This has been a homework question 2 times, as well as being addressed in class. And what happens when I rotate a line segment 180 degrees around its midpoint, Tyson? Well, that is true for the next question when we're using the whole diagram. If all I have is just this segment, I won't have those parallel lines line up just yet. Just the segment. What's happening, Parker? It lands on itself. I'm doing it now on the screen, rotating that 180 degrees around its midpoint, and it lands back on itself. That's important to note. We're going to write that down right here. The line segment lands back on itself. The next question is, now what happens when we rotate a line 180 degrees around a point not on the line? So again, if I'm rotating around a point on the line, it lands back on itself. That's what we saw in our last one. But what if I rotate, now I'm just going to take this line segment here. What if I rotate around a point that's not on the line? Experiment with that one. I'm going to rotate this line, line K. I'm going to rotate that around M because M is not on the line. What happens when I do that? Rotate it 180 degrees. Rotating it around M. Where does it land? Where does it end up? Is it back on itself where it was originally? Where is it, Landis? It is parallel. Let's answer that question there too. The line is parallel to the original. And now, finally, we are ready to answer the next question. What if I'm going to do that with the whole entire diagram now? So again, we trace the whole entire diagram. What happens now when I rotate around M? What I'm specifically looking for is this. Part 4 says, find a rigid transformation showing the angles MPA and MQB are congruent. So let me highlight those angles. MPA, that's this angle here in red. And MQB, that's this angle here in red. I'm trying to figure out a rigid transformation, remember all those hints that I gave you? That is going to take this angle to show that they're congruent. Experiment. I've basically given you all the hints that you need. Experiment with your tracing paper and your table. See if you can figure out how to show this angle is the same as this with the rigid transformation. Ready, set, go. And what did you discover? What is the transformation that I can use? Good. Cole? You're close. I need more details on that. A rotation around point M. Good. 180 degrees. Rotation 180 degrees around point M. It can be clockwise or counterclockwise. Because it's 180 degrees, it ends up being the same no matter what, and so that's why we're a little bit lazy and don't specify. Great observation. Let me show you what that looks like. A rotation 180 degrees around point M. So here it is, rotating around point M. That blue is what I colored in around P, and now what do you see? Wow, that's the same. So we were able to use a rotation 180 degrees around point M to show that this angle that was red is the same as this angle that is also red. And that is a new thing that we are going to call, well, I'll tell you in a second. I'm not going to give it away yet. Here's your next diagram. This one says, in this picture, lines L and K are no longer parallel, but we still have M, the midpoint of segment PQ. Is this going to work the same way as it did in the last diagram when the lines were parallel? Raise your hand if you say yes. Raise your hand if you say no and you don't even need to experiment with it. Okay, eyes on the screen. I've got it ready to go. Let's see. Let's see if we can rotate this 180 degrees around that midpoint M. Are any of those things lining up the way they're supposed to? No. Because, here's something cool. Look at K. Here's K rotated. Do you notice how K and rotated K are parallel? Yes, but is it the same as L? No, because it's not parallel to K. And notice the same thing. Here's L. Here is rotated L. Do you see how L and rotated L are parallel? But again, it's not the same line as K. And so we're going to write our answer down here. Does your argument in the earlier problem apply to this situation? No, because the lines aren't parallel, so I can't rotate it 180 degrees. I can't rotate it 180 degrees and have it land on itself. And now we're going to go back to the last diagram and add some notes. When we have parallel lines cut by a transversal, we have some interesting properties. Last time we talked about those corresponding angles being congruent, and this time we're talking about a new concept. And that concept is actually labeled right here in the activity. Alternate interior angles are congruent. We're going to write that down and talk about what it means. Alternate, right back on this diagram that we were working on. Alternate interior angles are congruent. It's a lot of big words that explain a fairly simple concept. Okay, you guys were able to rotate it so you know that this angle is congruent to this angle. You know that. We did it with a rigid transformation. But instead of having to do that rigid transformation every single time and get out our tracing paper every single time, we call this property alternate interior angles are congruent. What is this word right here? Interior. What does that mean? Callista. The inside. So, do you see how we've got parallel lines? Those parallel lines are like a boundary, a border. So we're talking about the angles that are on the inside of that border. I've highlighted all of the inside or interior angles. I'm also going to write that down. Interior just means on the inside. On the inside of the parallel lines. So just to really make sure that we understand this, we would also have exterior angles, right? Exterior would be the ones that are on the outside. Just knowing the opposites sometimes help us understand the meaning of the word a little bit better. Exactly. The ones that are facing out are the exterior. The ones that are facing in are the interior. And we also have this word here that we want to talk about, alternate. What do you think that word means, and why is it necessary for proving these angles are the same? Look at where those angles are. I want you to quickly discuss with your groups first. Online learners are going to have that quiet think time. Why the word alternate? What does that mean? Okay, now let's come back so that we have enough time to finish this up. Alternate, what do you think that means? Why am I choosing the word alternate? Nadia? Yeah, different or opposite, exactly. So specifically, what is different or opposite about these angles? Because we've already talked about how these angles are actually the same, right? They're congruent. So what is different or opposite about them? Callista? They're on opposite sides of the transversal. You got it. This angle is on the left-hand side, and its congruent angle is on the right-hand side, because they're on alternate sides. That's why we use alternate. Exactly, because they switch sides. We would also have this angle here. I'm going to go ahead and color code that one. Let's make that one, I'm running out of colors, purple. What would be the alternate angle of purple? It would be this one that is on the other side, the opposite side here, right? Those are alternate. Alternate. And again, alternate interior angles are congruent. It makes sense because we rotated them to get them into that position. Okay, let's summarize. We've made it to summary. So even though the cool down is next, we're skipping the cool down. We're going to come back to the cool down after we summarize. Summarize is always first. Sometimes I print them in backwards order so that it works a little bit easier. Again, I'm going to color code here as I highlight. When two lines intersect, vertical angles are equal and adjacent angles, that's a new word that we'll talk about. Adjacent angles are supplementary. Supplementary is not a new word. Who knows what the word adjacent means? It's a big fancy word that means next to. Okay? Audrey is next to or adjacent to Cambry. That's all that it means. No, it doesn't mean vertical, it just means next to. Here's how I'm going to highlight to make sense of it. You already know vertical angles are congruent. So vertical angles would be like this angle here and this angle here. Those are vertical angles and they're the same. Adjacent, however, it is exactly like that, 2 and 1. Do you see it now? And that yellow kind of got lost in the shuffle. You can't really see that yellow anymore. Exactly. These are 2 different angles. So what is important about those angles? Adjacent angles that are 2 different angles are supplementary. Supplementary, you might remember, means it adds to 180 degrees. So we focused on that vocabulary word yesterday being supplementary. We just need to maybe adjust that thinking to adjacent angles. Angles that are next to each other add to 180 degrees. They're supplementary. Check it out. 110 plus 70 adds to 180 degrees, right? They're just supplementary. Adjacent adds to 180 because they are supplementary. Altogether, yes, the whole thing would add to 360, but we just like to focus on the 180, the supplementary. And we already know the vertical angles are congruent. Those vertical angles would be angle 2 and angle 4. Those are vertical angles and they are congruent. We also saw this yesterday. We saw that when we have 2 parallel lines, so again, let's make sure that we understand the differences here, because this is where you guys got mixed up in your vocabulary this morning on the warm-up. We don't have parallel lines here, do we? And without parallel lines, we can still see vertical angles, and we can see our adjacent or supplementary angles. Okay? When I now add in a parallel line, we have another property, and that is the alternate interior angles that we saw today. When 2 parallel lines are cut by another line, remember that's just called a transversal, we end up with 2 pairs of alternate interior angles. So again, let's take a look at that. Interior means that they're going to be on the inside. And alternate means they're going to be on alternate or different or opposite sides of that transversal. Alternate, interior, meaning on the inside, angles. And they are congruent. I would say the whole thing. I would say alternate interior angles are congruent. It's a long one, but I would justify with alternate interior angles are congruent. Okay? And again, the rest of that is just explaining interior means on the inside or in between those parallel lines, like we already wrote down. And then it's just going over the example that I already gave. I do want to add something that we observed yesterday that is not included in our summary, and that is about corresponding angles. Again, we needed our practice with that according to our warm-up. That's something that we forgot. So we're writing it down here, corresponding angles are congruent because they are the same lines / angles after a rigid transformation. Specifically, a translation. We translated one parallel line to the other parallel line, and it matched up those angles yesterday. And again, this is explaining here, this paragraph is explaining, we know that alternate interior angles are congruent because we can rotate them. We actually did that. And here's the last thing to highlight. Using what we know about vertical angles, adjacent angles, and alternate interior angles, and corresponding angles, we can find the measures of any of the 8 angles created by a transversal in those parallel lines if we know just one of them. For example, we're just going to do the cool down. So now let's return to that cool down. Here are parallel lines that are cut by a transversal, and only one angle is shown. This angle here, 54 degrees. Online learners, pause the video long enough to answer each one of these questions. Find the measures of A, B, C, D, E, F, and G. Pause the video now. All right, what we should be seeing here is 54 degrees. I know the measure of angle B because of vertical angles. B is also 54 degrees. Again, probably a good idea to get in the habit of writing down how we know. We know this because vertical angles are congruent. I know the measure of angle D as well. I know the measure of angle D because I'm going to relate it to the measure of angle B. Notice that it's on the inside, just the same way that that's on the inside, but they are on opposite or alternate sides of that transversal. So using alternate interior angles, I know that this is also 54 degrees. And again, this one's a long one to write. Alternate interior angles are congruent. And I'm going to use a different property this time to show the relationship between B, which is 54 degrees, and F. And that relationship is corresponding angles. So I know F is also 54 degrees, and the justification I'm using here is corresponding angles. You don't have to use the exact same justifications that I am using, but I want to point out that the reason we've gone through all of these different properties is because they all have value. We can use them to help us find all of these missing angles. So corresponding angles are congruent. And now we need a new strategy because we've used all the strategies that we can to find all of the angles that are 54 degrees, but now we need a new one. What is the relationship between 54 degrees and C? And I hope that you recognize that these are, as it mentioned in the summary, these are adjacent angles, or angles that are next to each other, and adjacent angles are supplementary. That means they add to 180 degrees. So knowing that they add to 180 degrees, I have 180 minus 54, and that tells me that this is 126 degrees. Again, that was 180 minus 54 is 126. That's how I know. And again, I can check 54 plus 126 does equal 180 degrees. And again, using a lot of justifications here, we can take this information and use this to know that this is 126 degrees, so we can find the corresponding angle G is also going to be 126 degrees. We could take these angles here, 126 degrees and 54 degrees, and I can reuse some vertical angles here. 126 degrees means that E is also going to be 126 because vertical angles are congruent. And again, that same justification here, if this is 54 degrees, then its vertical angle is also going to be 54 degrees. Notice that we already found that using alternate interior angles, but it's really nice to see that it confirms the things that we already know. Depending on how we choose to justify it, we can see that same information. That's it for today. You do have homework. Your homework is the lesson 14 practice problems. Yeah, that's it. Have a good one. We'll see you next time.